Now let's move into one of the most important part of working with your data, exploring and understanding your data. Because before you do any analysis, before you build any model, before you do any cleaning of your data, you need to actually know what your data looks like. And Pandas gives us some super simple but powerful methods for doing that. Now I am going to create another file with name of exploration. Create a new file, exploration03 exploration.py. This is the name of my file. In here again I am going to import pandas as pd, then again I am going to import numpy as numpy np, and in here I am going to create a new dictionary with name of data, and inside this dictionary first field will be id. Inside id will have range 1000 on to 10 to on. This is the range, and this range function is Python inbuilt function, so we don't need to import that. Again I'm going to create another field with name of name. The name, this field will be a type of array, Alice. Okay, I have copied those names. There are a few names in here. Again I'm going to create another field with name of age. Inside this age we'll create some random age with numpy np dot random int. The age will be between, the lowest age will be 18 and the highest will be 40. Let's make it 40 for now. I'm not going to waste a lot of time on writing all of them, so I have just pasted all the values with key and fields in here. And this is salary, the np random int, this is the salary. We want 20 salary in here, and the lowest value will be 18, highest is 14. And in here size will be, let's say 20 as well. This is size. Department, I hope you understand how this works actually. Now in here we are going to create our data frame with df underscore employees is equal pd dot data frame and data. Now we want to add a value to our data frame. For that we are going to use .log function or method. Okay, OISS, and let me just copy this and paste it below here. Here I'm going to use this method LOC. With this we need to do like this. The square bracket in here we need to specify the number, the index number, which is going to be 2. In index 2 salary, actually let me just print it out so you can understand better. df employees, and let me comment it out for now. Now let's run run 03 exploration, and this is our data. We have this in index 0, we have this record in index 1, and we have this Charlie record in index 2. So I am going to change the value in index 2. So in here we want to change the salary. Okay, and the salary will be now numpy nen. So there won't be any value. Let me just run this again. Here is index 2 Charlie, and we have salary. This actually this shouldn't be like this. Okay, in this line df employees and we are selecting salary column. From salary column we are making it type of float. Previously it was type of integer. Now let me run this, and here it is. Here we got all the salaries in float values. I guess you know the float means. And this none is not working somehow. Actually let's make it none. So let's see, is it working or not? Still not working. So we'll work with it later. For now I'm just going to make it, let me just print it out. Print df employees, then we'll select array. Inside array will have name, then department, then we'll have salary. Before this ending first bracket we need to do like this. We have used this head method previously. It actually provides us 5 rows by default, but if we specify 3 or 4 it will provide us 4 rows. Okay, so let me just run it. It is not correct. Actually we need to pass square bracket here as well, and again run it. Yeah, it is working. Now we are only getting name, department and salary. All other columns are excluded. Yeah, now let's print again. Actually df dot tail, this is the function we are going to call now. Print df underscore employees dot tail. By default the integer number here is 5. We'll get the last 5 rows. So let me just run it again. Yeah, we are getting last 5 rows from 19 to 15 index number, and all those are here. And tail function is also helpful for checking the end of time series data. Usually in real world it used to check most recent data. Let me just copy this and paste it below here, and in here instead of 5 we want to get 3 rows from the end. So let me just write it, and here we got only 3 rows. Previously we got 5 rows, now we are getting only 3 rows. We are going to use sorting. This is very important to learn in pandas. df underscore sorted data, df underscore employees dot sort values. We are going to sort by salary. So by is equal this square bracket salary. Make sure this salary field is inside the data or data frame actually, and this is, we are not going to sort in ascending order, therefore ascending is false. Let me just make it, and here it is. Actually we should do like this. Print df underscore sorted. Let's see how it looks. Yeah, it is sorted now. The first one is 6. This is highest number of salary he got, George. The lowest number of salary taken by Fiona. Now we'll work with information, which is df info. For that we need to do like this. Df underscore employees dot info. We should get the information about our data frame. Here we are getting the information. Data d types, data types is boolean, and date time 64 US on float 2. Okay, those are all related to data types, and the memory usage is 1.6 kilobyte. All the information you got from these DF employees. Then again we are going to use something more advanced. Let me just copy and paste it below. In here, memory usage, let's say memory usage is equal to deep. Let's see how it works. You see, a little bit deep. Now we are going to work with describe function. This function is used to calculate descriptive statistic for numerical columns only. Hope you understand by this description. Let me just print it out. df underscore employees dot describe. Let's see how it looks. Yeah, it is describing actually. Okay, here the count is 20. We are actually getting 20 IDs. Age is 20. We have salary for 20 person, rating, everything should be 20. So this is the count means. This is mean means the lowest value of age, lowest value of ID, which is on 1000 and on. Lowest value of age is 19. The same way you get minimum value, you also get maximum value and standard output as well. And this mean actually mean the arithmetic average value. 25% mean the first quartile or 25th percentile. Same goes for 50 and 75% as well. Let's look into some additional data exploration methods. First of all, let's look into columns. Let's print df underscore employees dot columns columns, and let's take this inside a list. Actually the list will be like this. Okay, now let's run the file, and here we got all the column we have. Additional data exploration, this is the print statement we have made earlier, and after that we got all the columns in an array. Hope you understand this. Let me just copy and paste it below here, and here instead of columns you just need to write index.to list. In here you'll get list of all index number you have from 0 to 19 we have in our case. Now one interesting thing I want to show you, that is how many dimension we have in our data frame. To show that, to see that, we need to do like this, n dimension, n dim. Okay, now let's see, it should always be 2 because actually we are getting an error. Actually this is not a list, so let me just get rid of this list and run this again. We are getting 2 because data frame is always 2 dimensional. It won't change anymore. Okay, now let's check total size. Actually the total number of elements we have in our data frames by using this size, and again run this. We got 180. You just count all of them, you will get, actually not all of them, you just count all of them from here and you'll see we have 180 cell. And again we can see the memory usage for this data frame. Let me just call memory usage and run the file again. This is the details of memory usage. We have index of 132, ID 160. This is the number of memory we have used, bytes by byte. We can see how many unique value we have by just doing this, Control D, and in here memory usage, in the place of memory usage let's make it like this: department dot unique, department, department unique. How many unique value we have in the department? So there are 5 unique value in the department column. Okay, now let's do boolean mask of missing value. So let me just copy this again and paste it below here, or just duplicate it. In here I want to call a function that is null value, is null, and dot sum. How many value? Sum means total. How many numbers of value is null in here? Actually we got length of 5. We have total 5. Now let's get opposite of null value, which is not null dot sum. Let's see how this works. This is actually we are going to get non-missing value count per column. In a column, how many values is not null? I multiplied dash multiplied by 40. Let's see now. Here it is. In ID field we have 20 value. All of them has value, none of them are null. Actually this is all we are getting with null value. We don't have any null value in here, but in here we are getting non-null value, which is 0. We have value for each cell. Let's make null for one of them. Let me just make it. Yeah, now let's try again. 19 cell has value in salary column, but one of them has null value. That is why we are getting 1. Hope you understand. Let's take a look at some quick statistical functions. Let's do mean salary. So print if mean salary is equal df underscore employees, and select salary field, salary, then do call MEAN, and afterward let's do like this, comma dot to f. Let's see how it looks. Okay, here is the mean salary, which is $68,547. As we used this mean function previously, it actually calculates the average of all values in the column. Hope you understand. Like we did for salary, we can also do the same for age. We can get the average age. Yeah, average age is 29.60. This won't have a dollar sign because this is not a unit. Now we are going to use std function. Let me just copy this and paste it below. Instead of mean, just make it std. This is standard deviation. This actually measures how spread out the values are from the mean. It will be age and it will be standard age. Okay, so let's see. The values standard age is 6.2 on. If this value is low standard, then values are close to average. If it is high standard, then values are widely spread. Let's call another function, control D, and this is going to be projects, and this will have projects and will have projects dot mean. With this function we'll get the highest value in the column, actually the lowest value in the column. So let's see, we got 1.00, which is the lowest value in the project column. Same goes for mean, max. Same goes for max. Let's do a little bit of filtering of this data. So for that, actually it is not it, dt underscore employees, actually not dt, it will be it. We are going to filter by it, so dt underscore employees. Let me just copy this dt, not dt, it will be df employees. Inside this square bracket, df employees dot is manager, in place of is manager we are going to check department is it. If department matches with it, then we'll return those data. So let's check it out. Yeah, we are getting quick filtering. Yeah, actually let me print it out. Print it underscore employees. Let's see how it looks. Yeah, we got 5 employees. First one is Charlie, Ian, Michael, Samuel and Tina. All of them has department of IT. Hope you understand. Now we can use multiple condition. This is just only one condition. We can use multiple condition as well. Let me just copy this and paste it below here. And after this we need to take this inside parentheses. After that we need to provide an and sign, not double and sign. There will be only one and sign. In here we are going to pass again another parenthesis. In here df underscore employees is the salary of employees must be greater than, actually let me check, salaries of employees must be greater than 40,000. Let's make it 60,000, so we'll get this 3 value. Okay, so let's make it greater than 60,000. Let's see how it works. Actually let me print it out. This will be high paid IT employees, high paid employees. Print it out, all high paid employees. Let me run this again. All of them are high paid employees. We just cut out these two, actually this on. This is how we do filtering.